Welcome to the Bytecode. I'm your host Shafu, and today's episode is with Ross, who's going to walk us through some smart contracts too,
Yeah,
but smart account stuff. So, Ross, thanks for
yeah.
taking the time.
My pleasure to be here, and always nice to talk to my fellow chefs. So hopefully, I'm screen sharing correctly. If people kind of follow my Twitter account, they see that I mostly post about Solidity, and more or less lately, I've been on a sort of deep dive on smart accounts. Smart accounts promise to make Ethereum and smart contracts actually usable by doing things like batch transactions as well as using paymasters to abstract the need to hold gas. So that sort of like conceptually has been a sort of problem space I've been looking at. People who have followed my code in the past may have noticed I've done some other things. I worked on the SushiSwap AMM project for 2 years after working at Consensus on the OpenLaw project. So there's been a little bit of variety in sort of my arc as a Solidity coder, starting as a corporate attorney, looking at smart contracts for companies, now looking at smart contracts for users themselves with smart accounts. In my mind, this all interconnects, and I do try to, try to document that on my journey as well. But I really enjoy the opportunity to hop on sort of podcasts and calls like this because I really think in most ways, the code speaks for itself. So if I was going to point people at code I'm looking at a lot lately, I tend to point them at my accounts repository. A lot of my code bases are sort of licensed or deployed under sort of DAO accounts. I see a lot of the protocol work I do as sort of inviting sort of like open composition with other developers and sort of co-ownership with users. So that might explain in some ways how I view sort of how to deploy the code I'm working on. Largely, it's through a lot of these sort of code bases and organizations I work with. So for Naughty DAO accounts, something that, I guess the problem space that I first had to look at as a developer and has been a topic that a lot of people have been on about these days is what are these standards I need to worry about? The chief standard for sort of quote unquote account abstraction is sort of the dragon to slay so far has been the so-called ERC 4337 account abstraction using alt mempool. I'm saying my EIPs out loud now as a hat tip to Benteg. I think like the alphabet soup or like the serial barcodes of EIPs we all have to learn lately has been a little bit too much. So to kind of like bring it back to square one, this EIP basically just asks us, the developers, to think more intelligently about how we want our users to pay for gas when they call our smart contracts. They use a lot of sort of highly technical, specific concepts in the 4337 standard. Luckily for smart contract developers, all we have to worry about is the so-called I account, which just calls for us to just add a validate user out function. But to sort of like bring it back to what I've been working with that standard is, sure it's nice to add these functions, but to bring them all together in a sort of like united or sort of like reference implementation of a sort of smart account has been sort of my task, and that brings me to Nani accounts. So Nani accounts is something I launched earlier, or I guess I should say at the late end of last year, as sort of a way with other sort of developers to create the most optimized and gas efficient ways to use these like new fangled standards. I've worked with vectorized developers from kernel zero dev on sort of the Solidity 4337 implementation, which some people might have scouted a bit. Solidity is a very active repository of sort of like Solidity edge lords like myself who kind of like want to push and find like the most gas optimized ways to do certain things. Most commonly, most people care about Solidity to use libraries like Safe Transfer Library. That was kind of my introduction to gas optimization. When I was working at SushiSwap, I realized that, yeah, like 90% of what we do is just sending ERC20s and doing safe transfer from. Why don't we have a like extremely optimized way to do these repeat patterns? So things like Soulmate and Solidity, I think, have been like very nice sort of co-developed resources, and that the amount of sanity checking and auditing that using like low level assembly code requires almost takes like an army of developers. So I think it's like been pretty promising that like when we want to tackle new sort of patterns. Like, lately people are talking about new curves for signing. The like the curve signatures. But P256, we've recently slayed that dragon to allow people to add passkeys to their smart accounts. In a moment, I'll point to a sort of contract I've developed with this reference in particular, but all in well, and sort of to bring this ramble to sort of a focus is the accounts repository in Solidity. We have a couple of ingredients here that I think like will stand out to developers. First of which is probably, obviously at the top, our implementation of a contract signature helper. And I think a lot of developers who really want to test like their knowledge of any standard, specifically this one, could look at this and sort of be exposed, to theory meets practice. So a lot of this code has been developed for the simple purpose of allowing people to like claim airdrops from like their Gnosis Safe or other smart accounts. But I think people can begin to appreciate that just the simple problem of allowing somebody with a smart account to claim an airdrop, that has given way to a lot of very interesting and exotic code, one of which is the examples I'm looking at here. But for our purposes, and for my purposes with Nani, is we were able to develop in a pretty short sprint the most efficient version of the 4337 standard smart account. And this is measured by a sort of resource that some developers can look at that's maintained by ZeroDev, which is the AA benchmark, where they actually look at common transactions that developers and their users are going to do. The Solidity account so far has
Yeah, Ross,
been sort of the...
just FYI, you're still sharing your GitHub if you wanted to show the other page.
Oh, wonderful. So this whole time I've just been staring at my GitHub. Oh, okay, cool. I think it's on a tab basis. So let me see if I can share that, or I'll just put this like in the chat, and maybe that would be like a thing we can show at some point, is the AA benchmarks and sort of the gas skull thing that account developers are going into at the moment. But yeah, that's something to look at. GitHub ZeroDev app /AA hyphen benchmark. And
Yeah, just
sort of see how
FYI,
people are
if
approaching it.
people are interested in Solidity, for example, we did a previous episode with Vectorized. So look into
Yeah,
that if you want
the
to see some
master. Yeah.
inline assembly magic.
Yeah. No, he's fantastic, and I think like just the 1271 reference sample, I think will expose people to a lot of the more esoteric or dark magic things he's been up to lately. Um, yeah, anyways, but yeah, lo and behold, we were able to, like I said, in a short fashion, come up with the most optimized smart account. And then, obviously, once you create something like this, as a developer, you have to resist the temptation to make it too complex. So you have a nice starting base. The exercise I wanted to, hopefully other people looking at Solidity code or other references like this can be inspired and realize like you can actually kind of build your own code around these like hyper optimized snippets, and do so in a way that's like really not intensive and doesn't add too much surface area to like what your auditors might be asked to look at. And luckily Solidity has gone through I think at least 2 rounds of audits. The latest has been Cantina. I believe they're also going to go into an audit specifically of the file I was talking about, the 1271 file. And yeah, that should put a lot of us at ease. I think just getting a lot more eyeballs on this stuff. But like I said, the sort of strategy that I've employed when I work with Solidity or any library is, if I'm going to add code, I'm going to try to, keep the scope very limited to exactly what I want to do. So what do I want to do with Nani accounts, and what do I want to do specifically with this implementation? Well, I want to have an account that can easily be multi-owned. So multi-ownership is something that, I think comes naturally to a lot of people that have wallets with, significant sums or permissions that are valuable to them. You usually add permissions such as like another key signer on like a Gnosis Safe. You might even use MPC or Cold Wallet. The point being that, with smart accounts, very obviously, if we want to make these things secure, we should make it simple for them to have multiple ways to sort of be owned and to add different people over time. So something I do want to expose developers to is, when you're approaching the problem space of like, okay, I have a base to work with, now I want to add features, you really do yourself a service by just like popping open the EIPs, the actual EIP library, and like kind of scouring it and seeing like what has already been invented or sort of templatized in this fashion. So when I was approaching the issue of like obviously we need more flexible ways to own these the smart accounts, there's already a very basic standard around ownership for contracts. So yeah, like it seems obvious to me if I have the need for these things, I'll just add this puzzle piece or this Lego into my soup. So that's something that fortunately, Solidity and a lot of accounts like Alchemy Light Account supports is the notion of being able to transfer the owner. Now, what can I do with that hook, being able to transfer my owner, and what can I do with the file I was just talking about, where a contract can be understood as the signer for something? This brings me to Dagon, which is a concept I've been building in the public for a couple months now, which is I want to coordinate people around the idea of multi-ownership for smart accounts, but through a singleton. How does Dagon work? What is Ross even talking about? It occurred to me that like, we can add in the Gnosis save format separate owners as an array of owners. We can have a sort of multi-sig out of the box for smart accounts, but it seems to me to make sense as well to just say that the concept of ownership of your smart account will just be set up to whatever smart contract you end up transferring ownership to. So Dagon is a sort of master singleton developed to be sort of an app extension to smart accounts that allows you to take your Alchemy Light account. You can even take a Gnosis Safe smart account. You can take a Nani smart account, which I'm talking about today. You can install the Dagon singleton, and then you can add as many owners as you want. You can give these owners different weights of ownership, and you can set a threshold. So, for example, you can have your smart account. You can then say, I want to form an LLC, and I want to use this smart account to receive USDC from my angel investors who might be cutting checks to fund this endeavor. It's all going to be on chain. Like I said, you'll use USDC, but the investors and yourself might be concerned with, oh, there's only one guy who owns this smart account. What if this entire investment or runway gets compromised because he loses his key? Obviously, you're going to want to add more signers, more security. Dagon is set up in such a way that most smart accounts that just support EIP 173 transfer ownership and the contract signature standard is valid signature. They can just install Dagon right now. It's on every blockchain, and they can add a threshold for their signers. So 2 out of 10, 5 out of 10, 7 out of 10, more secure. And they can also set up in such a way that certain signers have more weight than others. So you can have a sort of CEO role who has like 60% of the shares, and then the remaining sort of members of the smart account might be able to coordinate and vote together to overcome that or something like that. There's like numerous strategies that you can sort of employ with the basic concept of a weighted multi-sig. So that's one design approach that I think we're doing that is unique in that what I want to present from the basis of smart accounts and from the basis of, from my perspective, every Ethereum and blockchain user is flexibility through singletons, which are separate standalone smart contracts that are offered almost as like app extensions to smart accounts. So I think this is also a direction, if I can just keep rambling. I guess you said like this call is mine, so I can kind of just like almost like lecture about this stuff is, we can go with the strategy that I've seen in the past where a lot of platforms have bespoke smart contracts. They have a factory for their bespoke smart contract. And every sort of user has a deployed instance of that smart contract, or they're sort of logged in with an interface that only works with those smart contracts. The approach that I'm trying to employ with like Nani smart accounts is let's have the user account itself be simple, hyper optimized using like Solidity code and other ideas we all come up with. But then like let's also use standards and not platform sort of things to work with, such as the 173 standard, 1271 standard, so that developers like myself, if I want to add the concept of multi-sig or DAO, I just deploy singletons that work with these standards, and then smart accounts that support these standards can use them as apps. So I guess like in some ways I'm giving like a very technically driven explanation of the realization a lot of product people have, which is like an app store approach probably beats sort of a firewalled or a walled garden approach to building products these days. But I think it is well worth realizing that as smart contract developers, because people will also notice, I think, and especially in smart accounts, that there's a lot of EIPs and standards that are promoted as providing features that really look more like lock-ins or complications that advocate for a certain interface or untested assumptions that people might have because they want to build a product around their EIP. So I'm not the first person to complain about this, but I think there's some tendency of smart contract developers to almost be evangelists for products and not for actual interfaces or simple standards that the rest of us can work with. Not naming names because I'm just some guy on the internet. But I think what we can take from this, especially as like smart contract developers, is that if you can work with the consensus Legos, like I'm pointing out here with like these standards that I'm showing, like transferable ownership, contract signability, upgradability, that's easy to understand, then I think you stand a much better chance of your work having value to more people because you'll build something that other people can use without talking to you, and they can understand your work without having to talk to you because you're using something that's already very well documented. So that's been more or less my approach in a lot of these deployments is what can I build that developers can value? A, because it's very gas efficient. I'm using libraries they understand like Solidity and Soulmate, and then B, can they also understand how these smart contracts add value to them because they already know the standards I'm working with. So that's been sort of my journey in developing sort of the Nani account, which is an implementation of a 4337 account that works with a lot of different standards to allow you to do more things while still being very simple from my perspective. If you compare a Nani Smart account to another, bespoke smart account framework, you might notice that we have tried to, in my opinion, and sort of the Moloch DAO flavor, keep the code as minimal as possible. And I think we haven't lost out on some of the benefits of still being modular because fortunately we've offloaded a lot of that to the entry point and the 433 standard itself. The 433 standard basically already keeps track of certain things like nonces. It even also does very clever things by not even requiring you to have sequential nonces. They have something called semi-abstracted nonces where you can have different sort of sequences and different sort of lanes. In that respect, with Nani account, we've looked at that standard and said, why don't we just take the literal nonce that you provide for your smart account and use that to encode as well the validator you want to use with that transaction. So that's something that we introduced that I think is unique, and we are advocating it as a sort of casual standard, but more as an implementation, which is, if you want to use apps with your smart account, you just use our nonce logic, and then the smart account storage will read that nonce and it will return the validator for that transaction. I have a much simpler version of this concept in my isValidSignature function where I say if literally the selector returns storage for a validator, we use the validator and not the Solidity version of sort of interpreting that. So that's a little bit of a lot. I don't know if there's anything specific I can go into. There's other things that I've neurotically tried to optimize. Like some developers that are working with these account standards might notice that there's repeat validation that doesn't make sense. In most cases, the init code for user ops will always be empty. So in these sort of things, I do things where I don't bother case hacking, or I take other shortcuts that I think make sense to overall save gas. Something I can go into that I think also help explains my approach is singletons that I think hopefully cover most bases for users. I have a contract, for example, that allows you to set up social recovery. And this uses the singleton format that I'm talking about, where we just run validate user op. We even allow you to choose either the old entry point or the new entry point. We toggle through that. But basically, what I kind of am advocating here with my modular account standard, which others, Rhinestone, Alchemy, are advocating for their own approaches, is I think validator plugins and apps for smart accounts should literally just almost be the stand-in for validating that user operation. So when I install a plugin to a Nani account, It's basically, like I said, it's a nonce encoded thing. If you point at that plugin for your user op, all you're saying is send this entire user op data to that plugin, and then it sends it back. As a developer, I think this is very simple to understand because the 4337 standard only requires as a developer to add one thing to their account, validate user op. So if you're comfortable just adding one function to use sort of the Nani and what we call ERC 75A2 standard of um, plugins through delegated nonces, if you use our standard, you only have to add this concept of the nonce pointing to storage, and then on your plugin, you only have to add exactly the same function, validate user op, and then do a return. So that's an approach that I think is unique to us, and I think is particularly gas optimized because, as well as not trying to add any new functions to the table selector of the smart account, by using the nonce as the pointer, we're reusing that word that's always going to be used anyway for every user op. So these are shortcuts that I think make sense. They're in the spirit of Solidity, sort of like trying to push the envelope, but in ways that are sort of like well understood and other people sort of have pitched into. So that's a little bit about plugins I can talk about. There's so much to talk about here just in terms of like the smart contracts themselves. But what I've like really tried to explain, hopefully, is that my approach with this project for smart accounts, like my other projects that I'm developing, like Helios is sort of an example of having a multi-token DEX. My approach largely is to try and not to invent my own interfaces. My approach is to try and front run myself by working on Solidity and in the public domain on like new snippets that might be useful to me and other developers, and then trying to push those together into single deployments of those instances or contracts in the singleton fashion. So people that want to engage with my work, use my smart contracts. Hopefully, they can look at like a repository, like the Nani DAO accounts repository, what I publicly post on Twitter, as well as just like on my GitHub. Look at the address deployments I include, and then just interact with my work in that way. And ideally, things are self-explanatory enough because I'm just using standards and typical naming. Um, that's all well and good. Something I can say though, and might be more helpful for people that understand what I'm talking about from a technical level, but still don't understand what it means from a product side or app side. We'll deploy an example or a sort of showcase app for Nani Smart Accounts this upcoming week. On that, people will deploy a smart account using the Solidity account implementation and the plugin additions I just mentioned. They'll be able to use that on Arbitrum Layer 2. Those deployments will be sponsored by us, but a concept that I think will be interesting to people, and maybe the more interesting thing I could talk about on this call, is our deployment of a paymaster for the public and for not any smart accounts, any smart account that we call Neath. So Neath is a paymaster contract in the sense of you can put it in a user operation for a smart account and it will pay for your gas. But the way it pays for your gas is it uses Lido Finance. And what do I mean by that? What I mean by, it's using Lido Finance. Basically, to use Neath, you treat it as a wrapper token for Lido tokens. So when you deposit Ether into the Neath smart contract, and I can scroll down to that code, it mints you an ERC20 representation of your deposit. But, let's scroll. But what it actually does under the hood when you deposit is it swaps it to Lido tokens, and then it holds those Lido tokens basically in escrow for you. So when you have Neath tokens and you can send them to other smart accounts and you use the Neath Paymaster, is it will run a validate operation, and in that validate operation, if I can find my snippets, sorry, I know this is a little bit of a thing. In the validation, it actually hits Uniswap v3 pools directly and does the swaps for you. So to kind of explain this in a more simpler fashion is, rather than using other tokens or, rather than having sort of an off-chain way to pay for your smart account ops, it seems intuitive to me that like if people are trying to position Ether and proof of stake as sort of like an internet bond or something that people should probably be somewhat allocated to, like Ethereum and Ether staking, if a lot of users will already be holding LSTs or Lido tokens, I think it makes sense to provide them with a convenient way to use, proof of stake and other sort of safe yield to pay for their own gas. So in that sort of way, we can have sort of like self-repaying or self-charging wallets, and I think it could be very, very interesting to see this work at scale. Our sort of tests show, yeah, you put in some ether, you wait like, maybe an hour or depending on the amount, as much of it as a day, and then you basically get a free user op. This has been helped a lot also by like post EIP 4844. If we have sub-cent transactions, it really doesn't take very long for, even a modest amount of ether staked into Lido Finance to generate enough to pay for your user ops. So if anyone that wants to use this sort of NETH contract, it's only deployed on Arbitrum for now because I actually have to do a bit of custom coding around the Lido for each layer 2. Unfortunately, the Lido staked token isn't the same address on every blockchain. I have to do these custom deployments, but people who want to use NETH, all you have to do as a developer, and we'll release sort of an SDK to use NETH Paymaster. All you have to do as a developer is just include the NETH contract address as your Paymaster data. So you just add the 20 bytes of NETH as the address to this little field that I'm trying to zoom in on. If you have deposited in the NETH and you provide that in your user op, NETH will do all the swapping and backend accounting for you to use your Lido yield to pay for your gas, basically. So that's sort of this idea, and sort of what I'm trying to workshop here with like the brand of smarter accounts is like I want to have a very good, solid, future-proof base that I think is going to be around for a very, very long time. People can come to their own conclusions. I think about like how long certain companies will be developing their account implementations. People like Vectorize, I think, will always be in the game doing some sort of like optimization. So I felt very comfortable as sort of developer building sort of my account space into Solidity, and then sort of like in parallel fashion exploring some of these really cool things like passkey signatures in the open, and not trying to sort of like put too much of that into a specific company or a DAO or anything like that. I think that makes sense to me intuitively about like the longevity of the tools I want to work with. Open Zeppelin, not throwing any shade at them. I think they're also a marvelous example of like a repository that has achieved a sort of like Lindy effect and escape velocity that I as a developer can expect it to be always reasonably maintained with the latest Solidity compilers and fun things like that. But yeah, so from that base, I want to add these singleton instances. I don't want to add too much voodoo to my smart accounts like a multi-sig into the base. I want multi-sig, other concepts to be sort of apps that you install by changing your ownership or by using this plugin validator system that I'm talking about, where you just put a key into your nonce and then that points at your plugin that you want to use. Everything I build is meant, like I said, to work with any account, and Party DAO, Aragon DAO, Moloch DAO, they should all work with sort of the things I'm trying to build here. Similar and somewhat related, there's other projects that I've done in this vein of like trying to build things that like work with protocols permissionlessly. Something I can mention, I've recently deployed something called Safes. A problem that I noticed, and it's not even like a real problem, is that a lot of like wallet login or NFT gating services like Collabland, Guild, Dynamic Wallet, they don't have like out of the box, make it so that safe multi-sig signers can chat in your room, or limit your room or your token chat to just safe holders in your multi-sig. So when I was presented with that problem of just like nobody has an incentive or the time to just like add bespoke safe integrations, I realized, yeah, like everyone has had time obviously to add integration for tokens. Like the ERC 1155 token, for example, works with most token gating apps. So if I know that there's low incentive to do something specific, but there's already high incentive to do something generic, can I put the specific into the generic? Can I put the safe multi-sig system into something as generic as the ERC 1155 token standard? Good news, and the Solidity developers might like this example of composability. You can do that, and how do you do that? Well, you just read the is owner bool from a safe right here for any address you put, you know, and I alias addresses as IDs. That might be a little bit confusing to people, but hopefully isn't too confusing. In a multi-token instance, each ID can uniquely relate to an address of a user or an account. And that's a pattern that I think is going to be around for a very long time. That we want sort of almost like one-to-one representations between token IDs and addresses. In this multi-token instance, this 1155 pseudo token I deployed, each token ID is exactly one-to-one with each Gnosis safe address and every potential Gnosis safe address, as a matter of fact. So if you put in, the balance of, and your, APIs and, CollabLand, your token gating bots check the balance of an ID for a particular user. If you're using my system and my token IDs, or really my address for 1155 token, I've through this contract been able to add the ability for people to log into apps now using their safe just by deploying a smart contract. I think that is cool, and even though this is a small example, I think it's still significant that indie developers, Solidity developers, just for fun, as a prank, even they can deploy contracts that can add new kinds of value or make things even simpler off chain for people just by doing something like this. And I think that adds some relevance, context, and power to the sort of the guild of Solidity developers that, like, if we want to solve something, we can either ask or try to build social consensus around protocol changes, or can we figure out hacky ways to do it ourselves. And then the social always, I think, comes around to the practical, and if you can make things more practical through this, then I remain optimistic that things like tend to get better if you just like deploy the code. So that's one thing I've been able to deploy for people on every chain. All the stuff I'm talking about probably makes a lot more sense to developers if they just like look at my GitHub and kind of backtrack and follow the breadcrumbs of what I'm working on. But all roads lead in a lot of ways to me working with multi-token and singleton smart contracts to basically envelop a lot of existing protocols and make it a bit easier to govern them. For example, my Dagon pattern that uses multi-token standard allows you to add arbitrary tokens. So like Aragon DAOs can use Dagon to vote on special projects in a special wallet if they want to. I think those are more interesting and compelling paths as a developer than sort of focusing on projects that don't necessarily have much interrelation to my other work or to other protocols. It would be my goal with anything I deploy or work on that it has like significance beyond the immediate context and can relate to like other users and a broader context ideally. A last project I could probably talk about, because I know I'm just like really just like talking and talking, is my Intense Engine project, and this was sparked from sort of earlier work I was doing with ChatGPT and sort of wallet pop-ups. So to me and other developers, and no doubt countless developers at this point, we've realized that like LLMs are good at understanding user requests and commands. They're good enough at that and reliable enough to take the gobbledygook of like, oh, I want to do like this on Saturday, but I also am worried about XYZ, and turn that into perhaps an instruction to a smart contract that could be a series of calls. The things I've noticed though, and probably will be an issue for a bit longer in AI and LLM assistance for like doing smart contract stuff, is that there is still variability and there's still somewhat unpredictability in the output. Even a 0.1% chance of being very wrong about decimals or a matter of fact on the blockchain, I think presents a lot of risk to users. So I think that can partially explain why we don't already have ChatGPT assistance for most smart contract interactions, but in fact usually they're making or helping you do function calls that are then checked by other software. In that vein of other software or other things checking what agents do, human or AI or otherwise, it occurred to me that like, okay, so why don't we just have the command instructions of a transaction, send 1 ETH to Vitalik, just keep the string of that and use the smart contract as the translator. I think most LLMs can condense the gobbledygook of a bunch of sentences into something as simple as send 1 ETH to Vitalik and have some fidelity to that. But actually building the transaction call data, doing the ENS domain lookup, finding the right alias and address, I do not want to take chances on that. And in the product that I'm talking about, a dashboard for smart accounts that can have plugins and agents, I want to have included in that sort of project and available to the public something I'm calling Intents Engine, which is a way to go from text commands into smart contract transactions and call data. Now, how does that even work? It's not a complicated concept, but it takes a little bit of guesswork at what the common commands are. Luckily, when I was sort of like surmising about this and asking people, there's only like a couple things people actually want to do in most common cases, which is like sending assets and swapping tokens. So the Intents Engine V1 is largely built around that concept that can I go from, send one ETH to Vitalik to the actual like on-chain ENS aliasing and the way conversion and have that just work out of the gate. It does work out of the gate, fortunately, and I think I can show that here, and hopefully unpack that a little bit. So here's a sort of shell wrapper for what I'm talking about, which is the Intents Engine interface for smart contracts using texts. Let me send a little bit of ETH. So I think I have, like a tiny bit, 3 zeros and 2. So let me send 0.0 ETH to Zoros. I think I have aliased this on Arbitrum. Let's do it live. Nice. So we see the 0.001 ETH. Let me see the hex data. It'd be nice if MetaMask could just show the text here, but literally this is a hex representation of the command I just made, which is send to Zoros. I don't know what. Okay, let's confirm it. I get a little bit of the return here, but you can actually see this command is literally what I'm going to send to the blockchain. This app is a very ugly and raw version of what will be happening behind the scenes with agents that condense the commands to things like this. But this is for testers who kind of want to understand what I'm doing with the smart contract. They can go to ie.nani.eu and actually interact with the this command contract. Let's check the transaction, why don't we, and see if all is well in the world. Cool. Yeah, so I transferred ETH, and you can see my IE contract handled that, and it sent it to Zoros, which is my address. Cool. I sent from 9 to Zoros.
Yeah, Ross, you're still showing the terminal interface thing.
Okay, I switched. Okay, now we're in the good stuff. Hopefully it shows my Arbiscan transaction. No.
Yeah. Now you stopped sharing your screen.
I've stopped sharing.
Yeah.
All right, let me see if I can fix this once I.
No worries.
Okay, let's try that again. Presentation screen. Okay. Does it help?
Perfect.
Okay, wonderful. Okay, like I said, I had a text command translated by my smart contract. My contract sent some ether. Let's actually look at the input data. My intent is a string. This is a decimalized version of, the send ETH. And this was all handled by this contract. And we can actually look at the code here. And with that particular command, all it does, if I can zoom here, I never realized how hard it is to like zoom on a call sometimes. Okay, cool. There are helper functions for each of the steps that you see in that simple transaction. The first of which is sorting it between send and swap. So if we look at what I am even doing here, if we look at that, and honestly, I wish I remembered where everything was. Okay. When you call the command function with a general intent string like send or swap, I sort the action by the very first word. And this, I think, will also be an inevitable pattern that you usually start an instruction or command with a verb. So if the verb is swap, send, transfer, anything of that like, I put it into an extraction function to extract the send component, which will be the alias of the token name or symbol to the address I've stored here or hard-coded. And then the actual amounts will also be translated from text to UINTs or way conversions. That is something that I think probably at a high level seems reasonable to people that if you have text instructions, agent instructions, the first word can help categorize that, and that's a standard syntax I want to promote, into different kinds of transactions that a smart contract can actually understand, parse, and then return the correct identical output that the user would expect based on that text command. So I think that like determinism is important, and I think will make more sense to people as they want to trust sort of apps and agents to do more with their money. Right now, we're sort of solving for some issues where like the user is present, but they're still very annoyed or confused about pop-ups, the contents, handling of gas. That's a simple issue that myself and other developers and projects are helping to solve with AA and smart accounts. But like even when the user is present and it like is very easy, they're still not the opportunity cost of their time is still not very efficient. So like in my mind, the smarter account and the actual unlock of smart contract accounts will be sort of being able to do deterministic sort of long-term goals, such as a savings plan, DCA, other strategies, and having almost 100% confidence that like your agent or a human, anything you've delegated to, won't be able to screw up that command. That is like a minor point, but I think like expands the map for a lot of use cases of if you can trust your wallet to do something while you're not there, the amount of things you're going to want to do with your money, I think will like dramatically increase versus like you're present in your command chair and you're like trying to understand what you're doing. Like I think a lot of people, and we understand this about ourselves, we're not that smart. We're not as smart as we think we are. We're beginning to trust AI and the internet more and more with our own thinking. And yeah, we know that our attention is limited and we can't be everywhere at once. So I think like we're even seeing in the cultural meta, the Bumble CEO is saying that like the future of dating is your personal AI dates other personal AI, and in like that Black Mirror episode, you find your matches that way. I think like we're gonna see more and more of this automation of like your spending preferences, like your persona in terms of like your financial behavior, will also be doing these sort of things, but you'll have a sort of way to control it, and you can't do that kind of control fine tune from the EOA right now. New standards might make that more interesting, but they'll still always require some sort of smart contract, even EIP 3074. So what I'm trying to say with all of this, and hopefully it'll make more sense showing the apps and the actual use cases, is that like people do want to delegate, but they want to delegate in ways that don't just reintroduce custodians and bankers and trust again. They want to delegate the code, and they want to delegate to more automated thinking strategies and AI and stuff. So like as a smart contract developer, like the systems I'm developing ideally can work with these use cases, and the most simple use case of like delegation is delegation of intent. Can you understand what I mean, and execute accurately the meaning of what I'm saying? And for a long-term command, just getting it right, the exact amount, the exact asset you want to use just based on the words is one component to that. There'll be more sophisticated ways to solve commands that are more complicated than just send one ETH from A to B. You don't need like much more than a calculator to do that in terms of the smart contract development. But some things that I think developers that are interested in this aspect of what I'm talking about, of like there's sort of like atomic or deterministic human input, machine output. That's cool. We can bake that into a vending machine like IE that can be used through apps, and that is obviously interesting. But what I think will be more the challenge and very interesting to develop around in the future is sort of what I'm talking about with advanced sort of permissions and delegations and understanding people's own financial behavior based on all their public blockchain transactions. To do that kind of more complicated stuff, and what I'm talking about here is less complicated as a smart contract developer and more of an off-chain developer task, I think will require a lot of thinking about signatures. And that's why I'm very thrilled that Vectorize and other people are making very, very good implementations of 1271 in ways that users can like see the digest and be like, okay, I'm going to give my agent this allowance with this time period, and I can see exactly what that is. I don't just get a big old byte32 hash. I'm using EIP 712 and making sort of delegations that way. But on the topic of what I'm talking about, I deployed something called Permit Validator. And some developers that are working with the contract Permit2 might understand where I'm going with this, where Permit2 sort of evolved all tokens to allow for permit for EIP 2612. Signed allowances. Wonderful, great. But like, what if we want to do sort of abstraction, not just of like signed allowances for token transfers. We want to do like abstraction of signed permissions to do like Governor Bravo voting on Uniswap proposals. Like, how can we like add permission for an account to vote with your tokens? How can we add a permission for an account to call an escrow contract during a certain time period? So I think people understand that this is really a game of like adding function selectors to a recipe list of like things the contract can route and account for. But in that sort of lane of like what does permit to point or permit three look like really, I think it should work natively with smart accounts. Permit two does accommodate EOAs. I think we can accommodate the contract use case a bit more. And then permit three should allow arbitrary permissions, not just token transfers and allowances, but sort of allowances over any function call that can be parameterized as arguments and reasonably understood to have conditions like less than or equal to. That is something that we're doing in our permit validator. And as a use case, we'll add to the app a little bit later. It's more complicated than what I'm talking about with just deploying smart accounts that work well with gas and Lido for yield to pay your gas. These are all like entry level concepts to something new that I think will make people excited. But what I'm personally excited about a developer is like the more advanced use cases of like I can give a robot the ability to vote for me, next month, but then another robot will review their performance and either fire them or enhance their training set. Though those are more complicated but exciting directions. As a smart contract developer, I hope I can like at least rest in having a base level way to do these things I'm talking about on chain, just through, like I said, signed digest, the sort of validate user outflows I presented with plugins that work with things like this permit three concept that I'm talking about, where you can validate a call to any contract and conditions on that call, such as amounts, such as time period, such as like the correct output. You can have an agent vote no on every proposal, for example. I think these are cool things that people want to do and have computers do for them. And smart contracts obviously will be essential to all of these things because like we already have ways for agents to bluff, but like we need to have ways to like prove agents are wrong using the truth of the blockchain. So for example, like my IE thing that I showed a second ago, you don't even have to subscribe to my view that like we should use text commands to do transactions. You might at least subscribe to the view though that like it would be nice to have a view function to see that the words and at least the name DAI equates to the correct address on that blockchain. I think those things will always be useful. So on-chain token lookup, token lists, I'm all about these things that are like very open, sort of APIs for all of us to use for smart accounts. And I think that is also something that might be unique in what I'll promote and deploy is I will showcase other implementations. While I think like myself, Vectorize, and others might come up with very good ways of doing things like implementations, I think there's value also in maybe some of the plugin approaches that Rhinestone is advocating for. And there's also benefits and also even slimmer, more minimal versions of what I'm doing. And those implementations, because I'm using upgradability, those can be used by anybody that wants to deploy using my factory. You can upgrade into a safe smart account, for example, from the base I'm talking about. And that's maybe a topic that like I could reflect on for a sec if I'm given time, and the candle is worth the game. The thing I would reflect on is that like I used to really hate upgradability and refuse to include it. Like Kali V1 and sort of my Keep multisig, deployed under that brand. Are immutable deployments and instances. And that came from my perspective that like when I was encouraging companies to use the blockchain, I really had to understand what the blockchain did that was impossible before or actually different from what they're using on like Carta or off-chain accounting. And one of the things that the blockchain can do, obviously that old databases cannot, is it can provide an unchangeable database. It can have some elements of permanence. So in some of my work, I've tried to highlight how that can be very useful for things like a trust or a sort of like cast in stone board of directors over a grant or something like that. But for like user accounts, for the broader population and broader set of use cases, I really think like having max programmability is the way to go. So yeah, the way I've approached that and using these other libraries is there's great standards around this, such as I'm always forgetting the one 1822. I think that's the upgradability standard. UUPS, minimal proxy contracts, these sort of upgradable, clonable instances. That's a direction for smart accounts that is inevitable, and I am skeptical of people that would say that this should be like an immutable bytecode. I think users might want to turn their smart account into literally anything, and that's something that I've kind of come around on. For protocols themselves, though, I still think like generally immutability is key. So anything that I try to provide as like a building tool, such as like the Neath singleton, the Dagon multi-owner singleton, my factories for account implementations are all ownerless, adminless, immutable deployments. But the actual users themselves, I think, should be like upgradable proxies, more or less. So I guess that's not a very complicated idea, and hopefully like becomes more commonplace that like users as upgradable proxies, protocols as instances that are immutable, but then users and sort of their interactions with protocols can migrate between different instances of the user smart account, and they can also migrate between different contracts they call using interesting abstraction things like permit 2 and permit 3. So I think that's like kind of the world of the things I'm looking at. Mostly I'm looking at ways to make smart accounts better, because overall if we make smart accounts better, we make all smart contracts better, because we'll just have like more users. That's always a good thing, more TVL, more liquidity. But then like all the tools that I think smart accounts need to evolve into more interesting things like vaults or companies. I think we need modules that are very simple and use existing standards. And I am personally not really trying to advocate for too much in terms of that. So yeah, I'm a singleton maxi, but then I'm very much about keeping things simple, at least in all of these things. I think I've talked about like the biggest contracts. The other ones are like less interesting and probably more commonly understood. Rage Quitter is interesting as a sort of like finance Lego of like, can we allow smart accounts to give token allowances to token holders so they can rage quit and burn and claim tokens from accounts? This allows a lot of DeFi protocol DAOs actually right now, if they wanted to use Rage Quitter, they could just have their multi-sig or their DAO smart contract give an allowance to a voting contract that's like all token voted on, and allow reimbursement or reclaim or rage quit of funds that way. I think there's like use cases to talk about there, but that might be its own call. It's just like, how do we use rage quit creatively for all kinds of different organizations right now? That's probably a whole nother concept, but I think overall, hopefully I've given a good overview of like my approach to coding, which is like jam out in public, with smart people you respect and trust that are long-term players, like, Vectorize and T11S, and jam out in public to create the best instances of the common, recipes that you're going to use, and then try and apply those recipes in ways that are replicable, at least in terms of like people can understand what you're doing. You're using, standards that aren't just your standard. Like it's always the temptation. I could be like, oh, but there's the Ross contract signature standard, and not use like 1271. But then like, what am I even doing? Like I'm making my life more difficult. I'm making other people's lives more difficult. So that is also something that like maybe I could encourage younger developers. I mean, I like to think of myself as young, but who knows how haggard I look to some people. But I would encourage younger developers that like, it may be tempting, because I also hate reading other people's code. I hate reading other people's tests. It may be tempting to just ship your own version of a concept or a primitive. But once you play with these contracts enough, and once you see a hack happen, and fortunately I've never been hacked. My contracts have never been hacked. But once you see these happen at scale, you may begin to appreciate like that. It's simply not worth it in a lot of cases to roll your own. So the best you can hope for is finding like your tribe of like-minded developers, and you like roll your own together in the way you want that optimizes in a special way you want. And that I think has been healthy in sort of my journey because it's like people I think still like kind of like rail on Open Zeppelin, their approach to like developing, and like while that can be interesting to like have differing opinions, I think that the best thing that I've seen is just developers building their own toolkit and trying to rally developers around their toolkit if they have similar goals. And then we actually have some diversity of implementations, and I think like that's also been good for Open Zeppelin. I've noticed that they've embraced more assembly and like optimized patterns in the face of that being an emerging developer preference. So yeah, I think it's like all well and good, and just like I would always tell people like if you're not sure about something, just like post about it on Twitter, and if you're wrong, people will love to tell you how wrong you are, and that's always helpful too. So yeah, I definitely think people can get themselves out there a bit if they want to grow as developers. Yeah.
Nice,
But yeah,
Ross.
any questions?
This was extremely interesting, man.
I hope
Uh,
so.
yeah,
Yeah,
yeah, definitely, definitely.
I'll write some
So,
docs. Yeah.
yeah, I'm gonna link Ross' GitHub for you guys in the description down below for you to take a look at. Really, like I found the intense stuff really interesting. So I have a machine learning background. I did machine learning
Oh,
before
nice.
I did the crypto
Very cool.
stuff.
You get it.
Um, to be honest, I wouldn't trust it right now
Uh,
to,
Fair enough.
do transactions for me, but I definitely see a future where,
Hmm.
for low value things, for sure. Why not? You know?
Yeah. See there, trust yourself. I've come to trust myself less with some things. So yeah, it's always good.
But really interesting work, man. Yeah, Ross, thank you very much, man.
My pleasure.
This was really, really fun, really interesting. I definitely learned a couple of things. So, yeah, thanks for taking the time, man.
Yeah, thanks for letting me go on about my code. That's the best thing I could ask for. So
For
appreciate
sure,
it.
for sure.
Appreciate the time.
Awesome, guys. Then, thanks for tuning in and see you in the next one. Bye bye.
All right.